In this video, we're going to talk about exponential functions word problems. There are many types of word problems that require an exponential function approach. When faced with one of these questions, we can use the equation a equals p times b to the exponent n. When using that equation, a refers to the final amount of the quantity being considered. To help you remember, you might think that A stands for after. P refers to the initial amount of the quantity being considered. So to help you remember, you might think that P stands for previous, because it's the amount that you have previous to any or prior to any multiplying occurring within the exponential function, prior to the b, the base of the exponent, being multiplied. B refers to the multiplier, which is the base of the exponent, and n refers to the number of times that the multiplier is applied. So for example, in a weekly question, n would refer to the number of weeks, while in a yearly question, n would refer to the number of years. In one of these exponential questions, we will typically be given the values of 3 of the 4 variables. One of the most common difficulties that students have is dealing with the value of b. Now, let's talk about that a little bit, dealing with the value of b. And in doing so, let's start by talking about half-life questions. You might say, what is a half-life? The scientists keep track of the rate of decay of different substances by using a half-life. A half-life is the length of time that it takes for a given substance to decay to 1/2 of the current amount. So for example, if it takes a year for a substance to decay from 500 grams to 250 grams, then the half-life of the substance is 1 year. Since the half-life of a substance is constant, then it will take 1 more year for the substance to decay from 250 grams to 125 grams, and 1 more year for the substance to decay to 62.5 grams, and that'll go on infinitely. So in a half-life question, the base of the exponent is 1/2. In other words, b equals 1/2. Now let's talk about a doubling period question. Another common exponential function word problem question is a doubling period question. Scientists often use doubling periods to keep track of rapid population growth, for example in a population of bacteria. The doubling period is the length of time it takes a population to double in size. So for example, if it takes a population of bacteria 1 hour to grow from 200 to 400, then the doubling period is 1 hour. It will similarly also take 1 hour for the population of bacteria to double from 400 to 800. In a doubling period question, the base of the exponent is 2. In other words, b equals 2. Now let's talk about rate of growth questions. In many questions, we're told the percentage rate of growth over a given period of time. For example, imagine we are told that the value of an item increases by 6% every year. This means that after 1 year, there will be 106% of the original amount. To obtain this value, we can therefore multiply the original amount by 1.06. To obtain the amount after 2 years, we can multiply the original amount by 1.06 squared. And to obtain the amount after 3 years, we can multiply the original amount by 1.06 cubed. In summary, we can let the base be 1.06 and let the exponent n be the number of years. Of course, if this was a weekly question, in other words, if the value increased 6% per week, then n would be the number of weeks. N is the number of times that the multiplier needs to be applied. In summary, during examples of exponential growth such as this, the base of the exponent is given by b equals 1 plus the rate of increase, where the rate of increase is expressed as a decimal. Example, 5% is expressed as 0.05, making the base be 1 plus 0.05, or 1.05. There are also rate of decay questions. In many questions, we're told the percentage rate of decay over a given period of time. For example, imagine we are told that the value of an item decreases by 3% every year. This means that after 1 year, there will be 97% of the original amount. To obtain this value, we can therefore multiply the original amount by 0.97. To obtain the amount after 2 years, we can multiply the original amount by 0.97 squared. And to obtain the amount after 3 years, we can multiply the original amount by 0.97 cubed. In summary, we can let the base be 0.97 and let the exponent n be the number of years. Of course, again, if we were told that the amount decreased by 3% each week, then the base would still be 0.97, but the exponent would be the number of weeks. Again, the exponent is the number of times that the multiplier is applied. In summary, during examples of exponential decay such as this, the base of the exponent is given by b equals 1 minus the rate of decrease, where the rate of decrease is expressed as a decimal. So for example, 4% is expressed as 0.04, so if we were told that we had a situation where an amount decreased by 4% per year or per time interval, we would say that the base is 1 minus 0.04, or in other words, 0.96. Now let's do a few examples of some questions. Let's do some questions where we're determining the value of A. In other words, we know the values of P, B, and N. Here's an example. A ring has a value of $600 today. If the ring increases in value at a rate of 5% per year, what will be the value of the ring in 10 years? Well, A is question mark. Now, P, the principal, is equal to 600. That's the amount before any multiplying takes place. It's originally worth 600, and we want to know how much it's worth after 10 years. B is 1 plus that rate, so 1 plus 0.05, which is 1.05. And this is a yearly question. In other words, we're told the increase is 5% per year. And so since we want to know the value in 10 years, n will be 10. A is equal to P times B to the n, so that's 600 times 1.05 to the exponent 10. That's approximately equal to 977.34. So therefore, the value of the ring in 10 years will be $977.34 approximately. Here's another example. A car has a value of $16,000 today. If the car decreases in value at a rate of 14% per year, what will be the value in 8 years? Well, again, the amount after the decreasing is what we don't know. The original amount before the decreasing is $16,000. B is equal to 1 minus that 14% rate of decrease, so 1 minus 0.14 is 0.86. N is equal to 8 because we're talking about a rate of 14% per year, and this question is occurring over the course of 8 years, so N is 8. A is equal to P times B to the N, which is 16,000 times 0.86 to the exponent 8. That's 4,787.49. So the value of the car will be approximately $4,787.49 in 8 years. What if we talk about a half-life question? A particular chemical has a half-life of 60 days. If there are 20,000 grams of the substance today, how much will there be in 300 days? Okay, well, the final amount is what we don't know, so A is a question mark. P is 20,000 because before the decaying, or referred to in the question, occurs, the amount of the substance is 20,000. B equals 1/2, as we discussed before. The base, the B value in a half-life question is always 1/2. N refers to the number of half-lives. So what we're going to do is we're going to take the total time and divide it by the length of a half-life. So that's 300 days divided by 60 days, which is 5. So A is equal to P times B to the exponent n. 20,000 times 1/2 to the exponent 5 is 625. So therefore there will be 625 grams of the substance in 300 days. Now let's talk about examples of questions in which we're determining the value of P. In other words, we know the values of A, B, and N. Suppose a house has been appreciating, that means increasing in value at a rate of 7% per year. Today the house is worth $675,657. We want to know what it was worth 12 years ago, rounded to the nearest dollar. So in other words, we know the amount after all of the increasing has occurred, but we know that amount, but we're looking for the amount prior to all of that decreasing occurring. In other words, we're looking prior to all of that increasing occurring. We're looking for the amount 12 years ago. This is an increasing question. Appreciating means increasing, so 1 plus 0.07 is 1.07. N is equal to 12 because it's a per year question and it's taking place over 12 years. N is 12. A equals P times B to the exponent N. So 675,657 equals P times 1.07 to the exponent 12. I can divide both sides by 1.07 to the exponent 12, and I get this quantity equals P. Well, this is equal to approximately 300,000. So we can say the house was worth approximately $300,000 12 years ago. Here's another example. A hockey card depreciates at the rate of 9% per week. If the card will be worth $15 in 20 weeks, we want to know what it's worth now. Well, it will be worth $15. That's the after amount. That's the amount after the depreciation occurs. The prior amount is now. Now is before that other, now is before the $15 value. So that's what we don't know. Depreciate means decrease, so this is a decay question. 1 minus 9% is 1 minus 0.09, which is 0.91. N is equal to 20 because it's decreasing at the rate of 9% per week, and this is taking place over the course of 20 weeks. A equals P times B to the N, so $15 is equal to P times 0.91 to the exponent 12. So $15 over 0.91 to the exponent 12 will be equal to P. This is equal to 98.92. So the hockey card is worth approximately $98.92 now. Now, let's talk about questions in which we're determining the value of B. In other words, we know the values of A, P, and N. In these sorts of questions, we need to isolate B to the exponent N and then find the nth root of both sides, or equivalently, we want to raise each side to the exponent 1 over N. So here's an example. An investment grew from a value of $300 to a value of $800 in 20 years. We want to know the average annual rate of increase rounded to 1/10 of 1%. Well, the A value after all of the increasing, that's 800. The P value before all of the increasing, that's 300. B is what's not known here. We don't know the average annual rate of increase, so we can't know what B equals. This is a talk about annual rate of increase, and it takes place over the course of 20 years, so N is equal to 20. A is equal to P times B to the N. A is 800, and P is 300. So 800 equals 300 times B to the 20. We divide both sides by 300, and that equals B to the 20. Now, what we want to do is take the 20th root of both sides. The 20th root of B to the 20 will be B. We know B is positive in this case because we know we're increasing. And we want to figure out what's the 20th root of 800 over 300, and that is approximately 1.050. Now, remember, in a question like this, B is equal to 1 plus the rate of increase. Subtracting 1 from each side means B minus 1 is equal to the rate of increase. So 1.050, which is B, minus 1 will be approximately equal to the rate of increase, which means 0.050 will be approximately equal to the rate of increase, because 1.050 minus 1 is 0.050. 0.050 translates to 5.0%. When you want to figure that out, you move this decimal over 2 places. And it wanted to the nearest 1/10 of a percent, which means we wanted 1 decimal place here. So because we wanted 1 decimal place here, we wanted 3 here because we knew we were going to move the decimal to the right 2 spots. So what that means is the average annual rate of increase is approximately 5.0%. And let's do one more question. In this example, the value of a house decreased from $900,000 to $700,000 over a 10-year span. We want to know the average annual rate of decrease rounded to 1/10 of 1%. So the after amount, after all the decreasing took place, was $700,000. The prior amount, before all the decreasing took place, was $900,000. We don't know what the base is, but we know that n is 10 because we're asking about annual rate of decrease over a 10-year span. So a equals p times b to the n, which means 700,000 equals 900,000 times b to the 10. We can divide both sides by 900,000, and we get 700,000 over 900,000 equals b to the exponent 10. Okay, for some reason I wrote it twice. I don't know why I did that. But what we can do now is take the 10th root of both sides. So the 10th root of 700,000 over 900,000 will equal b. So 0.975 will approximately be equal to b. Now remember, b is equal to 1 minus the rate of decrease in a decaying situation. Well, adding the rate of decrease to both sides and subtracting b from both sides, we get the rate of decrease is equal to 1 minus b. That's approximately 1 minus 0.975, which is equal to 0.025. Now 0.025 translates to 2.5%. We move that decimal over 2 places. And we wanted it to 1/10 of 1%, so we wanted 1 decimal place here, which means we wanted 3 decimal places here because we wanted to move the decimal to the right 2 units. So that means the average annual rate of decrease is approximately 2.5%.